Hello, I'm Professor John Kelly, and this is the Weber Auto YouTube channel. In this episode, we are going to look at the inverter assembly out of a 2013 Ford Fusion Hybrid. Now, Ford calls it a transmission control module. They also call it the secondary onboard diagnostic module C. So right here on the table, I have one of these completely disassembled. I ordered one of these off of eBay. When I got it, it actually had water inside of it. Luckily, I didn't pay very much for it, and I only wanted it for training purposes, so it didn't really matter that it was ruined. But I took it apart and wanted to see all the internal pieces and see how the inverter assembly here from Ford compares to the other inverters that we've looked at, and I have separate videos on the inverters from Toyota and the inverters from Honda, and I'll be doing a separate video on inverters for General Motors. So let's take a look at the cases to begin with. This is a three-piece housing or case assembly. This is a liquid-cooled transmission control module. So throughout the rest of this video, I'm going to try to call it a transmission control module because it does control the Ford HF35 hybrid transaxle, a very neat, very cool transaxle. But I might also call it an inverter since that's what it does. Anyway, it's liquid cooled. We've got two cooling pipes in the front here that would be towards the front of the vehicle. This one is from the radiator, where it comes in, and if we look at the other case half that goes with it, right here, these two would be hooked together. It runs through all of these little passages, where on the other side of the passages we have heat sinks, areas where we have electronics that get really hot that will transfer their heat into the aluminum, which will transfer it into the coolant, which will transfer it to the radiator, which will transfer it to the air. So it's a giant exercise in heat transfer. The upper case half here has two heat sinks also with modules that get really hot. So this is actually the middle case, and then this is the upper case. There's a sealant that goes around here, a form-in-place gasket sealant. There's no gasket for this, and so these two pieces will bolt together just like that. The bolts that hold these two pieces together come in from the bottom. So we've got all these holes right here in the bottom that are going to bolt the upper case half and the center case half together. So let me quickly put those bolts in there so we can assemble this properly. I'm not putting sealant on here because I want to take it apart again with my students. One bolt left. I forgot. It goes on the outside right here. Okay, so this is the upper case, this is the lower case, or the center case, and then there is a lower case cover that will come in and go right there. So we are going to build this TCM assembly from the bottom up. So to start with, from the bottom up, in this lower cover, there is a vent hole. The vent, as I tried to remove it, a plastic piece broke, so I do not have the vent, but I do have the smoothing capacitor. Actually, there's three smoothing capacitors here. There are three 1100 microfarad capacitors, 1, 2, and 3, right there, that bolt into this bottom case here. Now, when I first opened up this case, it was full of water, and it was full of water because the way this inverter sits in the vehicle, the electrical connections for the high voltage three-phase wiring that connects the TCM to the transmission, the electrical connections are facing up. So anyone who takes one of these TCMs out of the vehicle, the electrical connectors are open and exposed straight up. And the service information addresses this. It tells you to put a piece of tape across these to keep dirt from getting in there. But apparently in a salvage yard, this was sitting outside and got full of rainwater or whatever, but it really corroded the inside of this lower case. Some of these bolts are pretty dark from the corrosion that was there. But anyway, I was able to clean up most of it for this demonstration. Now, these capacitors here, these three smoothing capacitors, these are the capacitors that have to charge up when you first power on the vehicle and the positive contactor closes, and then we turn on the pre-charge contactor. The pre-charge contactor through the pre-charge resistor charges this set of three smoothing capacitors. And when it gets charged, then the voltage on each side of the negative contactor terminals is approximately 0 volts, and that contactor can close. And I've got a separate video on the Ford battery system and that contactor setup and how that works. But this is the smoothing capacitor. It's a great big one, 1100 microfarads, 600 volt. It takes a lot of current to charge it up, but it charges very quickly. But if you charge this capacitor with the negative contactor, as you close the negative contactor, it takes so much current to charge this that it can jump the gap on the contactor's connections and arc and ruin the contacts in a short period of time. So the pre-charge contactor through the pre-charge resistor limits the current down to such a small amount. It's around 6 amps instead of upwards of 100 amps, that it won't ruin the pre-charge contactor contacts as they close. And then, as I said, when the smoothing capacitor gets fully charged, there's no current in the circuit, and you'll have 0 volts on each side of the negative contactor. So our big smoothing capacitor is bolted into the bottom case. There's an access panel on the side of the transmission control module housing here. This access panel right there allows you to get in and make the electrical connections, bolt them up and unbolt them. But as I said before, none of this is serviceable. With Ford, you've got to replace the entire unit. I take it apart just because I like to take things apart and see how they work and see what parts are the same. Now, the Toyota inverters and the Honda inverters that we've looked at all have a smoothing capacitor, a great big one, just like this, 3 of them, one for each of the 3 phases of three-phase voltage that is used to drive the electric motors in the transaxle. All right, we'll set this lower case cover out of the way for the moment, and let's turn this housing upside down and take a look at inside here. Inside, we have the outlet holes for the electrical connections to the transmission. And those outlet holes right there are filled with this bus bar assembly where we have 3 electrical connections per electric motor. There's 2 electric motors in the HF35 and the new HF45 transaxle. This particular connector is for the generator, the smaller of the 2 electric motors. The generator in the transaxle starts the engine and generates electrical power that charges the high voltage battery behind the back seat. This one is the motor connector, and that drives the great big traction motor inside the transaxle that moves the vehicle down the road. There are also 2 current sensors. There's a current sensor for the motor, there's a current sensor for the generator, and that's these black pieces of plastic here. We have 2 we have 3 sets of 2 bus bars each for the 3-phase cables. So 3 of these would be for one electric motor, 3 for the other, but they're not wired like that. This is the U phase, this is the V phase, this is the W phase. And in 3-phase AC voltages, they're typically called W, V, and U phases. Now on these transaxles, the V phase just stays there. The V phase never changes. But on the W phase and the U phase, if we swap those two, we can reverse the direction of the electric motor. So there's some special controllers. They're called IGBTs, insulated gate bipolar transistors, and there's 12 of them. There's 4 in each of these modules that will bolt down right here to these heat sinks and transfer their heat into the coolant, as we talked about before. But before we do that, we need to get this bus bar in place. There are 2 long wires here that have to pass through to the upper housing as we set this down in place. Just like that. So this bus bar assembly has 4 bolts that hold it in place. I'm just going to run those in by hand. Oh, I lied, it has 6 bolts. Okay, so we've got the bus bar installed. On the opposite side, where the electrical connectors from the transaxle come in, there are some plastic finish connectors that help keep everything held in place and keep dirt out from around the seals that are on the electrical connectors themselves, these black seals right here. Okay, so our connectors are connected, and we've got our bus bar connected. The next thing we want to connect up are the IGBT modules, and these modules I've got laid out over here. We've got 3 IGBT modules that have 4 IGBTs per module. An IGBT is a power transistor. It can turn on and off very quickly, can handle a whole bunch of current, and it also has a diode across it. And the diode is used for when we decelerate. It's used for rectifying the AC voltage and turning it back into DC. The IGBTs are used for taking DC high voltage and running it through the 3-phase windings of the transmission's stator assemblies. It still is DC, but they just change the direction of which that DC current goes through those windings. And since it changes directions, technically you could call it AC, but it is DC, and I'll prove that to you later. All right, so we have 3 of these modules. We have one for the W phase, which is this side right over here. One for the V phase, which is right here in the middle. And one for the U phase. Now, I forgot to mention, these flat surfaces here on the back side of these IGBT modules need a heat sink compound, or heat sink grease, as some people call it, to help the transfer of heat out of these components into the housing itself. Oh, by the way, notice I'm wearing an anti-static wrist strap. I have an anti-static mat over there that's grounded to the table, so I don't have an electrostatic discharge from my body to the electronics here. And of course, I'm not touching them anyway, but you should always wear a wrist strap for something like this, grounded to your, or connected to your table or bench, toolbox. So there's a very special procedure for putting the correct thickness of this heat sink thermal transfer grease on. Toyota actually has little templates that you put across here and a squeegee that you use to put a uniform layer of heat sink compound across here. And then they would have guide pins that you would line up the module on the guide pins and drop it down in. And in that case, I think the IGBT modules would go in before the bus bar, but in this case, I did the bus bar first. So each IGBT module is held down with 4 bolts. All right, now I'm not torquing these bolts. I'm not tightening them down in the proper sequence as I would if there were grease under them, the thermal transfer grease. Because once again, we're going to take this apart again in my classes that I teach on hybrid and electric vehicles here at Weber State University. Now, we have power and ground. These 2 terminals at the top of these IGBT modules connect to the power and ground from the high voltage battery. Then the other 2 terminals here on the opposite end feed the 3-phase bus bars. So we'll put the 3-phase bus bar voltage wires in first. This one does the U phase for both the generator and the motor. This one does the V phase, and this one does the W phase. Once again, we can reverse W and U on these and make the electric motor or generator turn the opposite direction if we want to use it as a motor. All right, so we've got our IGBT modules in, all 3 of them. We've got our bus bar in. The next thing is we need to get our DC bus bar installed that connects power from the high voltage battery to these modules. So we've got a nice copper DC bus bar here, battery negative identified, battery positive identified from the high voltage battery. Then we have a 20 watt 35.3 K ohm, so 3,530 ohm resistor. This resistor's job is to discharge the smoothing capacitor every time you turn off the power to your car and the contactors in the high voltage junction block open. This is what discharges these 3 capacitors. They're all wired in parallel with each other electrically. And then we have some voltage feed lines from the DC high voltage that goes up to the upper case to feed some of the modules that are in control of the TCM. So the first thing we'll do is put in our high power, high wattage resistor here. It's got a flat little spot off to the side here, a couple of Phillips head screws that hold it in place. All right, and then our DC bus bar is going to come in across all of those IGBT modules, and then it's going to transfer up through from the middle case to the upper case, and there'll be this access hole right here that these bolts will stick, or this bus bar will stick through. And there we can see it right there, to get the power from the high voltage battery once it gets to the TCM here. So there's a couple of electrical connections here. We've got the one for the resistor that drains the smoothing capacitor. And then we've got a couple others that feed power to a circuit board that we're going to install here in a minute. One in the lower area here and one in the upper area. So we've got the white wire right there, black wire right there where it has the letter B, and then our final bolt right there. So we are, once again, we are connecting battery positive and battery negative from our 281.2 volt battery to each of these IGBT modules. Okay, the next step is is to install this shield. This shield is both a heat shield and an electromagnetic radiation or interference shield. And it also functions as a bracket for the little computer that controls all 12 of these IGBTs in the 3 IGBT modules. So we'll set that in here next. It's got a guide pin right over here, and then 6 screws that hold it in place. Okay, the next piece that goes on is a electrical barrier, an anti-conductive piece of special paper here. Keep our circuit board from touching the shield as we install it. Just got some little clips that hold it in place with the plastic. And then we have our IGBT computer. I don't know what Ford calls this because they don't even address it in their service information, but Toyota calls it an intelligent power module for the IGBTs, so we will go with that. Be real careful with all the electrical connectors. A couple of guide pins there, and then several screws that will hold that in place. All right, next thing, we've got all these little 6 electrical connectors that plug into the circuit board that also hook to the IGBT modules down underneath. So since there's 4 IGBT modules since there's 4 IGBTs in each module, I suspect these 4 sets of wires are the controllers for those 4 on each module. Okay, we've got an electrical connection, needs to be made right here with our DC power feed that powers up this module. Then we've got a communication line that plugs in right here and goes to the upper portion of the case also. I should have fed this one through first because it's the biggest. There we go, got it through. Now we'll plug that in over here very carefully, and we're in. And then we'll put our current sensing wires for our 3-phase output back through the pass-through hole to go to the upper portion of the case. All right. Get the wires routed right here. There we go. Everything's in its own little clips there. We've got the 2 current sensing wires coming through. We've got the communication line, and then the 2 power feed wires also coming through on the top here. Now, while we've got the bottom exposed here, let's put our smoothing capacitor and bottom case on. And you can see on this DC bus bar right here, that's where the smoothing capacitors are going to bolt up. So we will line this up right there, drop it down, and then bolt down our bottom cover. It uses a bunch of 25 Torx bit head or Torx head bolts. Okay, I've got the case cover bolted on. This case cover should be sealed with the form-in-place gasket sealer. It was the gray stuff on all 3 of these sealing surfaces when I took it apart. You'd want to use something that is compatible with antifreeze. Let's see, on the bottom here it says FOMOCO, and then ESTYA. I don't know what that means. And then Japan. A lot of the parts inside of this say Toshiba on it. I'm sure that's a supplier for Ford here. Okay, with the TCM housing turned upside down, we can see the openings here for the connections for the capacitor. So there are 6 electrical connections and then 4 bolts that hold the cover on. All right, I'll just prop this up with a piece of wood so you can see what's going on here. So once again, these 6 electrical connectors connect the capacitors to that DC bus bar. And all 3 capacitors are the same size. Each capacitor hooks to a positive and a negative side of the high voltage cables. By the way, if you're impressed with how clean this aluminum housing is, it used to be really corroded and dark. And the way we cleaned it up is we purchased a wet sandblasting machine. It's incredible. If you've never used one or seen what one can do before, if you want to restore aluminum back to looking like it was brand new, a wet sandblasting machine is is the way to go. It's absolutely incredible. I've got some old transmissions, 60-year-old transmissions over here that just look terrible, that are part of another video series I'm working on, and we cleaned them up and they look brand new. It's absolutely amazing. Now these covers, this cover and one other one just like it, except smaller, should also be sealed with that form in place gasket sealant. All right, here in the upper cover we have 2 more heat sinks. One of them is for this great big one is for a great big giant coil of wire called the reactor. And the reactor's job is to, through self-induction, boost up the voltage from the DC battery. So we've got a 271.2 volt battery in this Ford. This boost reactor, as it's called, and it can also buck, which is to reduce the voltage, can increase the voltage higher to give the automatic transmission, the hybrid transmission, more power. But then it will also, the transmission will deliver more power back than the battery can handle, so this will step that voltage back down also. So that sits in here. It needs a special thermal heat transfer grease on it, guide pins to guide it in place, I'm sure. And then it is controlled by another IGBT module, but this one just has 2 IGBTs in it instead of 4 like the ones in the bottom. It has 2, one for boosting the voltage up and the other one for bucking or bringing the voltage down. So that sits in here next. So 4 bolts per each of those 2 modules I just put in. All right, the next part we're putting in is a current sensor. Measures how much current the boost or buck reactor is producing or receiving. So we'll set that in here. It's got a couple of Phillips head screws that hold it in place. And then it has this copper bus bar for transferring the current through the boost module from the reactor. Okay, the next component to go on is the electrical connector that connects the high voltage battery to the TCM here. We have the input battery negative and battery positive right here, and then we have the output of battery positive and negative right here for the high voltage air conditioning system. Across the top here, there's a high voltage interlock circuit that will open up the contactors in the battery junction block if somebody pulls this cover off. And there's a fuse that goes across here that protects the electric air conditioning compressor circuit. There's also another high voltage interlock circuit right here in the cable connection to the high voltage air conditioning system compressor. It's an electric air conditioning system compressor. It's fed DC voltage, and then it has its own built-in inverter assembly where it changes that to a three-phase AC voltage and runs the air conditioning compressor with a three-phase synchronous AC motor. Okay, now that we've got the electrical connector in place, we can put in the next piece, which is what's called a filter capacitor. Every hybrid and electric vehicle inverter I've seen has a filter capacitor. It has a smoothing capacitor, that great big one in the bottom, the big three in the bottom. And then this one has a little tiny filter capacitor also. There's two of them in here. One of them, the larger one here, is a 207 microfarad capacitor, and the smaller one is a 0.954 microfarad capacitor. And this capacitor just sits in this open hole off to the side here, just like that. Okay, then we've got a wire harness, a couple of wire harnesses we need to make sure are free. Next, we have 3 bus bars that we need to connect in the top here. So we've got one going from battery positive from the high voltage cable from the battery to the reactor. Okay, so this bus bar I just installed, battery positive to the big coil of wire, the big coil of wire's negative side through the boost inverter module, the controller of it, to ground. And the ground is provided through this big bus bar right here. And right below this bus bar over here, we have one more bus bar that connects the big bus bar from down below in the lower case, the big long bus bar that connected to all the IGBT modules, connects it up here to the boost inverter module. There's 2 screws here that will go through these holes right here, or that hole right there, to make the connection. So we've got battery positive, battery negative, high voltage connecting right there. Our battery negative for the boost module right there. And then a couple of bolts that hold it all down. Okay, I connected the lower bus bars to the boost inverter module up here and the negative bus bar. The 2 connections for the lower bus bar to the upper bus bar are right here, and there's a cover that covers that up. This cover should be sealed with the form in place gasket sealer as well. Okay, now we've got 2 loose eyelet wires up here that are voltage feed, voltage sense wires. They have Phillips screws, Phillips head screws that hold them down. We've got a blue wire that goes on the battery negative bus bar, and we've got a red wire that goes on the battery positive bus bar. All right, so we are ready to put the hybrid vehicle control module circuit board in the top here and get finished up. Just a quick review here of the operation here in the upper portion of the TCM, the inverter assembly. We've got battery positive and negative coming in from the battery through this connector off to the side. Battery positive comes into the big coil of wire, the reactor, where then it's pulled to ground through the boost inverter module over here, and the ground is provided through the electrical connection to the battery over there. Then we have a separate power and ground connection that goes through this pass-through connector that feeds DC positive and negative 281.2 volts to all 6 of those IGBTs modules in the bottom or in the center case housing here, that then uses those IGBTs to run current through the 3-phase coils of wire in the HF35 transaxle, and now the HF45 transaxle. I understand it's improved, a little more reliable, a little more efficient in the 2017 and above vehicles. All right, so we've got a boost inverter module, a controller for these 2 IGBTs right here, and a thermal shield, electromagnetic shield, and a bracket for the hybrid vehicle control module that's going to go in here next. So we will set this down carefully. Make sure all our wire harnesses are free. Looks like they are. Let me get the screws for these. There are 2 extra long screws. One goes right there, and the other one goes back here in this corner, that go through lower components before they attach to the case. And then we have just shorter screws for the remaining. We have this little copper attachment. It's kind of a riser to hook another screw to. All right, we have one IGBT electrical connection that needs to be made. And then we've got a hold down clip over here. This wire goes through, and a couple of hold down clips, or one hold down clip over here for our 2 current sensing wires. And then we have another barrier here, electrical barrier. As far as I can tell, it's to just prevent electrical connections from occurring on the circuit board versus the lower portion. Maybe it's a moisture absorbing piece of paper. I'm not sure. If any of you know what that is more than just a insulator, put it in the box below. All right, now we've got our motor generator control computer, which is the overall control of the entire assembly here. There is an external electrical connector that interfaces with the transmission and the body harness, and that is going to slide in here before our motor generator control computer, and then our motor generator control computer goes in right on top of that. There's a guide pin right over there, and another one right here. Let's put the screws in here. All right, we've got our motor, generator, control computer bolted down. Now we have a few electrical connectors to connect. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 connections to this circuit board that we must be very careful and make those connections. Get the little clip in place. There we go. Another connection right here. One right there. One right there. All right, now we've got a harness that plugs in to our boost module down below. Right here. And then comes over and plugs into the circuit board right there. Has its own little bracket, and then one last electrical connection right there. Okay. Lots of screws, lots of circuit boards, lots of modules, a lot of components. You can see why maybe they wouldn't want people going inside of these and servicing them, but Honda and Toyota let people go in and service theirs. So I don't know if it's just a matter of cost or training or whatever it may be. So we've got our lid, of course, but our external electrical connection right here has a hold down bracket right here that holds it in place. The seal around this electrical connection is the regular form-in-place gasket sealer as well. Then we've got the upper lid, the upper cover here. It's also sealed with form-in-place gasket sealer. It has a warning symbol on it for high voltage and shock hazard. So we will set this on here like that. There are 2 extra long bolts right there, and then the rest are just the same length going all the way around the cover. I can take off my wrist strap now. I'm not touching anything sensitive. All right, one of the last pieces to go on is called the expansion tank. Expansion tank right here. I want you to notice this expansion tank only has an inlet. It has no outlet. Yes, you can open this up and put coolant in. This is where you put the coolant in for the electronics cooling, but there is no inlet and outlet like on most other hybrids and electric vehicles I've seen. So this is going to bolt right here to the side of the case. As the fluid expands, it will come up. As it heats up, it expands. It'll come up into the reservoir here, the expansion tank. And we've just got the quick connect fittings right there. Okay. This is the front of the inverter. Once again, we have coolant coming from a special section of the radiator dedicated for electronics cooling. So we cool the inverter, we cool the automatic transmission fluid, the HF35 and 45 fluid. We have a coolant outlet that goes to an electric water pump that circulates it through the radiator and the inverter. We've got our high voltage cables coming in from the battery. We have our high voltage cables going out to the air conditioning compressor. We have our air conditioning compressor fuse on the top here. We have our high voltage 3-phase electrical connections right here. And let's just bolt those up at the moment. Just like that. There are 3 bolts that hold down each set of cables. Okay, so there's our 3-phase electric motor that drives the vehicle down the road, and then our motor generator, which both starts the internal combustion engine and acts as a generator to charge the high voltage battery, that then is fed to the front of the inverter where it's inverted into 3-phase voltages to drive the electric motors in the transmission. All right, let's keep turning here. We've got our access panel, we've got our transmission electrical connector and our external harness connector, and then we have our capacitor pass-through bolts connection right there. So that is the inverter assembly. This is just an inverter assembly. It does not have the converter with it. The converter is part of the high voltage battery on the Ford Fusion Hybrid and Fusion Energy. Now, these leftover 2 harnesses here with 3 wires apiece plug into the automatic transmission, the HF35 parallel axis transmission, which is the next video that we will make and look at. So I hope you stick around and watch that video next. Thank you for watching.